And we hope people can drag themselves away from the basketball games or whatever they're
that could be.
involved in. I don't know.
Okay.
Ready for this?
I do chocolate tidbits. Yeah, you have a nice show. It's close in. It's on your phone. Close in. Water.
Oh, close. What do I want? And if you're looking for salad. I'm going to say like stuff.
No, that's first off. That's first off. All 6 units.
For 2 weeks.
I thought we're on.
What region are you looking for?
No, we're still doing the one. You have noticed that on
There's the mesoscale regions, and then there's a Midwest one. There's a southern Wisconsin one for mesoscale that only is active when the mesoscale region covers that area.
This one, I thought I got to it from a totally different page.
Oh, well, yeah, there is the mesoscale visible IR and water vapor loops are visible from are available from that first page, or first landing site. I have no idea. Yeah, I would expect more people to be there. You said John was going to be late.
He's going to be late, and Melissa I haven't seen.
Huh.
I'm sure it's not.
Well, we can certainly discuss the weather anyways. See if they have any online changes. We have 4 friends online, so. Huh? I don't.
Off the radar. Satellite. Operator. Radar, satellite, operator. Forecast.
Was John going to be here at all?
Yeah, he's gonna come. Yeah, he just had the exam, so there's something.
Got it.
Greg's here too.
Yeah. It's bizarre. Greg was around these things.
He had to get a doctor's appointment. He was early.
A graduate student.
What's it?
Huh?
Oh,
Hi.
where is everyone?
We have more people watching online than we have in the room right now.
Maybe everyone's just watching online.
I guess they're watching basketball or something.
They're watching it online now, so now that you did it this
We have 8, 7 watching right now. Yes, they're
You're up. You ready?
Oh, yeah.
whatever.
I'm really rich.
You wanted to start with that?
Yeah.
I do have to read mine, so higher than the water vapor.
You look at some of that, I guess.
John have a test today or something?
Uh,
Oh, yeah,
Which class?
100.
Oh, yeah. So they're sorting through that. Okay, we're gonna get started, I guess right now. Welcome to Weather Watch. I'll start off with the discussion of today's weather. John Martin will be down here in a little bit. For those of you that are unfamiliar or online and haven't watched in a while, Weather Watch is our weekly discussion of the past week's weather, current weather, and future weather. And what we're gonna talk about today will be really rather quiet weather that's going on over us. An interesting potential East Coast weather event next week. We get south of the loop right there for a second view. And we'll talk a little bit about, kind of curious to see John's reaction to a new set of tools that we haven't used before from an online page that they just put out called some cross sections. You might look at the cross sections through the East Coast event from last week. Now, if you recall, last week at Weather Watch, we were talking about some uncertainty with respect to snowfall in the Mid-Atlantic region early the following week, early this week. And as you may know, there was a significant weather event, significant snowstorm right along the eastern part of the United States into New England with very strong winds, 60-mile-an-hour winds, snowfall totals in the Boston area in excess of 2 feet in some areas, and just a really powerful storm where some parts of southern New England and the New York area got very little snow. So we'll look a little at that. That's not going to be the focus of today, but I think we might have an opportunity with some time left at the end to sort of dissect this storm. So this is a satellite image from Monday evening, around 9:15 Monday evening along the East Coast, just as the cyclone was just really beginning to get going. This is an IR image, and we'll let this animation go, and we'll stop at a couple points just to see the really well-developed structure of this storm. Here's a nice stop right there, with a nice, very obvious comma head, very broad area of very high cold cloud tops. And this is going into the day on Tuesday. And there's really nice banding of snow. We have the radar from that time period. I don't know if we do have that loop available or not. Okay. You would have seen some really nice, well-developed bands of snow, very heavy snow, that was centered over eastern and central New England that produced those really significant snowfall totals. We let this continue to go forward in time. Cyclone began to move out. Really strong northwesterly winds and a lot of snow showers that remain. Our forecast city, for those of you who are in the forecasting contest, Binghamton, got a few snow showers during the course of that day. Now we're up to the 16th. This is today, and we have yet another nice, well-developed swirl in the central part of the United States, and we'll look at that on the radar and look at the precipitation with it, and then come back and look at it on the surface. We'll look at some various elements in the structure of this. Here's the precipitation. Largely rain in the southern part of it, and convective precipitation in the southeastern part of the United States. But again, a really well-developed sort of common head in terms of the radar imagery and the satellite imagery. A lot of this is snow in the northern part of this map. We'll go to just one additional link here, which will be pivotal, just to see where the watches and warnings are across the country. Click on that, I guess. We go back to home. So you can see currently, winter storm warnings are these purple areas or pink areas, the blue areas that extend around this region, and then just to our south into the Mid-Atlantic, West Virginia area are winter weather advisories for snowfall. And so we're going to look at the progress of this storm, and it's located over the Central Plains, and we'll see its track is actually going to be off to the southeast, weakening with time, just skirting past us over the weekend. So it's a really quiet weekend for Minnesota and for Wisconsin, with a lot of precipitation that will be well to our south. This red area here are red flag warnings. This is potential for fire, dry conditions, and very strong winds, so the risk of fire there, and then some flooding potential along the Mississippi and some of the tributaries in the southern part of the United States. So with that fire in the central, we pull up this coast 16 on the mesoscale imagery. new band that I put on there is a shortwave infrared band, and it's very sensitive to temperature at the ground. And I have it colored so that fires on the hot end show up orange and yellow, so you can actually see some of the fires that are going on right now.
This is really
One of
neat.
them right there. One of them right there.
Pete's pointing out with this new IR band that he's producing the imagery for, not the imagery for, but posting images of the imagery in this band. You can actually see where there are fires at the ground. Those are color coded by Pete, so that's kind of a neat feature to see.
This is a strange band because there's a component of this frequency that is reflected solar as well. So during the day, the IR temperatures on as a whole tend to be warmer, and when the sun goes down, then they get colder and the clouds all brighten up.
So it lakes, then?
I think those are lakes. Yeah, those are probably water lakes, liquid water lakes.
Really neat feature. Anyways, let's go back to the visible imagery for this the cyclone that shows up again in GO 16. The visible?
Like the CONUS.
No. CONUS. As a okay, so again, this is this, and these are every minute.
Every minute
For
the last hour.
For the last hour, GO 16 imagery, and you can see these sort of linear banded structures in the clouds right here, and that nice swirl that we saw here. But you can also notice the difference in the texture and type of clouds that we had here. A lot of cumuliform clouds that were on the southwestern side of this, and much deeper cumulus and some cirrus on the north side of this. So really a nice, and then low clouds on the north side of that cycle. So really nice sort of structure and texture to the clouds, and to get a sense of not only the circulation, but just the depth of the clouds. Again, this is imagery we would have been able to look at a year ago. So this is the latest in U.S. satellite technology, both the temporal frequency of the data as well as the extreme resolution.
There are some other RGB component imagery or types that have been developed that they use the different satellite frequency bands as red, green, and blue channels for a color image, and the different colors then tell you information about what kind of thing you're looking at, whether it's an ice or liquid or dust or various things. And there's a number of those that I'm hoping to get up as well. That use the different frequency information, the 16 different bands on the satellite to help identify different features.
Okay. So here's this current sort of depiction of the cyclone. Let's go back to the radar for the U.S. To the composite radar.
Too many tabs.
Too many tabs up, but that's all right. You can still hear in the back. Look at the precipitation. This is a composite radar loop, and you can see this broad area of precipitation. Mentioned this is snow. We'll look at the surface observations to verify where to go from liquid to precipitation to snowfall. Here's this other weather system along the western part of the United States with a lot of showery type precipitation along in California. And again, with a lake effect, perhaps over the New York State, and then this really broad area of convective precipitation that's going to be advancing across the southeastern United States. You can also see sort of a developing squall-like type structure in central Louisiana and eastern Texas. So that's the just now let's go back to the
Is there atmospheric river or something coming on?
we're gonna look at that. So let's look at the CONUS visible imagery one more time. Just a broader picture, and then we'll focus on what's going on in the western part of the United States. So here's a departing cyclone in the Canadian Maritimes and south of Greenland. There's this next cyclonic feature in the central part of the United States. You can see where we saw that linear band of precipitation in the developing squall line. In the satellite imagery, you can see the clouds a little bit higher, brighter here, reflecting sunlight back in the visible part of the spectrum. Here's that mid-continent cyclone. And then off the west coast of the United States, we'll look at the GOES west view, but a really deep trough, and you can see these cumuliform clouds here indicating really cold temperatures in the mid-troposphere just off the west coast of the United States. So fairly quiet day in the country, it's really up the Midwest, with a few clouds over Lake Michigan heading to the southeast, with these clouds advancing from the west, so that's indicative of cold air advection if you assume the relative flows are geostrophic. That's a backing of height of wind profiles, so that's deep cold advection over us. Let's go to the western part of the United States. Infrared. So this is the infrared imagery. And you have this really deep cyclonic circulation off the western part of the west coast of the United States. And with that southwest flow, impinging upon some of the mountains and the terrain just off the west coast or inland, getting those showers and cold cloud tops. Again, post-frontal is often when they get their precipitation in the western United States. It's really cold air aloft, and these cumuliform clouds producing shower precipitation. Further to the west, north of Hawaii, we see this nice plume of enhanced cloudiness, perhaps an atmospheric river that's beginning to develop out of the tropics and subtropics approaching the western part of the United States. We'll see how that evolves in the forecast. That's one sort of surge of moisture. And then further to the west, a second one. So the Pacific is getting active. I don't know, John, from your perspective, is this more active than we saw earlier?
A little bit, but it's still been remarkably absent most of the winter of a really deep cyclone in the Gulf of Alaska or along the ocean chain. There's been a few, but it hasn't been, one after another. That one looks kind of weak. But the one off the California coast, Oregon coast is interesting. It's beginning to be the climate time of year for those things.
Right.
Really
this is the time for cutoffs to begin.
Yeah, that's right, especially there. So that gets to be kind of interesting. Look at that cloud blowing up on the southern side of that cyclone near the end of the Aleutian chain. The one
Right here?
that just blows up quickly. I don't know if it's all high clouds, but probably not. That's a really interesting expansion of the cloud there. Rapid
I
too.
wonder if there's just at the tip end of the vortex right here. Maybe
Right.
Of it.
Along
You can see that.
Barracloon zone.
Right. Barracloon zone here, and then the little vortex interacting with it might be generating a new cyclone. So that'd be something to sort of watch in the forecast. Okay. Let's go. We did look at surface maps, so go look at surface maps over North America. Look at the big plot first. Moving on home. Here we are, 31/14, relatively dry with some clouds, but off to the western part of the state, across 35/7. So really dry air here. That's one thing that's going to perhaps help us out a little bit this weekend. The fact that it's relatively dry, a piece of falling going to evaporate before it reaches the ground, but also the overall direction of that cyclone is going to be well to this moving east and southeast of us.
Or it'll cool the column sufficiently to drop it as a snowflake, which I know you're looking for.
Yeah,
You're rooting for that.
they're actually, if you look at the GFS plumes, the potential, if you wanted to believe that, in some of the ensemble members for 5 inches of snow this weekend. That's not going to happen.
Categorically, yeah.
Right. Well, I've said that before, like 2 weekends ago, and we were totally wrong. Here in the central part of the United States, again, that mid-continental circulation that we saw, look at it. You can see at the surface, looks really well over southern, south central Nebraska. Really clearly a nice cyclonic circulation, probably down to 993 perhaps, or 992, just south of Lincoln, or southwest of Lincoln, Nebraska. Really nice circulation there. Moderate snow at this station. That's not Grand Island. I don't know. That is what, Sydney?
I don't know. Is that North Platte? Maybe it's North Platte.
That's not,
Okay, so Platte 36/33 with moderate rain. Just go to the north, moderate snow in this location. Drizzle. These sites freezing drizzle. In fact, and a couple of these.
Look at the temperature contrast across the Kansas-Nebraska border. It's 64, and I don't know what that station is to the west of Kansas City. 64, 39, and 37 over 35 directly with 90-degree wind.
Really nice. Yeah, I would ignore this.
Yeah.
These lines on here. I think the front's right there. It's probably going to be right up here with a nice wind shift across it and precipitation just north of it. So that's a really nice front. So we've got snow falling here, a little bit of freezing rain in these sites, and then just plain rain to the south. And that's where we saw some of the winter storm warnings as well as watches that extend to the southeast of it. We go down to the southern part of the United States. Okay. Nice and warm over Texas, 76/63. Where's College Station? We got College Station 77/65, which is a nice day down there in the southern part of the United States. It's somewhat humid, kind of muggy with dew points in the mid-60s, but it's not super hot just yet. And we go across to the western part of the state, so you see a slight wind shift. There's even a dry line here. That's supposed to be analyzed, but we have a big drop in the dew points from 75/62 down to 76/34. So really dry air over in western Texas. Then out ahead to the southeast, where we saw some of the convective precipitation, there is a gradient in dew point. Dew points in the mid-60s here, and then in the low 50s here and just sort of plain rain. There's no site here reporting moderate or heavy rain down there to the Gulf Coast. But there's no evidence of these stations at this, the stations that apply here of thunderstorms, just plain rain shows up here. So it's rather normal precipitation. Nice quiet day. I bet if we go up to New England, we'll see probably colder temperatures. It's colder here than it otherwise would be with the deep snowpack that they have over parts of Boston, 35 over 15. It will probably easily be in the 40s today, I imagine, without the snowfall on the ground. And then here's some of these light snow showers, light snow that's been reported at the stations in New York State. That is Bennington, isn't it?
Yeah, I think so, yeah.
I went 0. Can we check out the op for Bennington today?
0.13.
Wait,
0.13.
you went 0.13 for today?
No, that's what happened.
Oh gosh. For those of you not in the know, and it's clear I'm one of those folks, we're forecasting for Bennington, New York in the National Collegiate Weather, or the Weather Challenge forecasting contest. And I defiantly went 0, even though we're at maybe 100th or 200th of an inch of precip, but hearing from Zoe that it was 0.13. What'd you go, Zoe?
0.01.
You had to do that. Okay. BGM. BGM. Yeah,
So
BGM.
That's a benefit, both for being in the right category, rather than.
Oh, but just wait. Well, hold on.
Oh, sorry.
Oh, wait. Actually, it was, you said it was 0.13, so I'm going to get burned. If we go to 12Z, look at the 12Z total for precip. It's, right there. Hey, 12Z, they only had 700s already, so that was the first 6 hours. Yeah, it's a bust for today.
Yeah.
More snow than, Mother Nature didn't actually do the right thing in terms of what the weather should have been.
You were thinking about Cooperstown, where it hasn't snowed yet.
Probably,
Yeah,
that probably is. So there's this light snow in New York State. Unfortunately, it's a little bit higher. I'm thinking about the team, not myself. I think our consensus forecast was probably lower than Zoe's, I think. I would hope. Okay, so that's what's currently going on over the continental United States. At the surface, let's now look at the upper air maps, look at the superpeats, as they're called. And I am going to start at 850 millibars. We look at a little bit. No, let's look at an image. Look at this nice, well-developed cyclone over parts over Kansas. You can also see a nice thermal ridge, and that's along the axis of that thermal ridge that would anticipate this, warm advection into it. You see that region of precipitation. Just the well-developed circulation, it gets kind of muddled as you get in terms of thermal structure back here. John, I don't know if you have any points you'd like to add about that.
No, just that I hate these maps now. I used to like them, and I don't bother even looking at them hardly anymore because they just don't really show any structures. Maybe it's because they have, I don't know how they're doing their analysis with the data or not, but they just never look that nice at 850.
850 you don't like?
Yeah.
Not the superpeat as a whole.
No, the
We can fix
superpeats
that.
are great. Yeah, the superpeats are great. They just, the analysis at 850 is always muddled now, even away from the high terrain.
Right.
So I don't know.
You can also see just broad cyclonic circulation in eastern Canada. This very narrow, skinny ridge that's sort of protecting us weather-wise today with a nice anticyclone maximized over here at our National Falls. And then this really deep cyclone that's over the central part of the United States. This was in the forecast last week. We're talking about this weather system moving across the southwestern United States into the Central Plains. So Greg had brought that up.
It's interesting, that structure of the low and the skinny ridge to the north and east reminds me of Scott Powell's heavy rain events in Colorado. You know, it's almost the exact same broad setup, it's just displaced a little bit further east and at the wrong time of year. But imagine if you have 60 dew points broadly going into the Dakotas, you probably get a big flooding event somewhere in the Dakotas, yeah.
These aren't the same as the Colorado events, because there they have very light and variable winds at 500 millibars. I think there's still some wind there.
Yeah, we'll look, but I think it actually does weaken. Well, so here's this cyclone that's off the west coast of the United States. Let's go up to 500.
Pretty windy, yeah. Otherwise.
We still have, again, the structure of this weather system is almost vertically stacked, but you can see it's weakened a little bit. There's a nice cyclonic turning right here, but also notice the change in wind direction, this very skinny, narrow ridge downstream of this trough. The change in curvatures and certainly favor some modest divergence, at least to its east. That's in the region where we're seeing precipitation. At this level, this becomes a much more prominent feature over the west coast of the United States. Remember, we saw the cumuliform clouds that were off the west coast of the United States, and here's the you can see the temperature at -34 degrees at Celsius, just off the west coast of 500 millivolts. Really cold air aloft, and that's roughly the location we saw those cumulus clouds. Nice deep trough here. This is probably less impressive at this level than it was at 50.
In my impression, I think for the first half of March, it's been at 500 millivolts. It's been really wavy over this sector of the hemisphere.
Yep.
And I think the whole hemisphere has looked somewhat like this, but this has been a particularly wavy first half of March. And it's probably not a coincidence that there's been 3 mega storms in the East Coast. And
right.
and this one today is pretty interesting for us.
So this is that waviness that we continue to see in the forecast. Let's go up to 300 millivolts, please. You almost lose this. This really gets kind of bizarre looking. You see the deep trough or the trough that's off the west coast of the United States or just along the coast. And then it's embedded within this broad ridge. And the jets are basically split, nice split flow. And a confluent flow, which is going to be important in the forecast, over the eastern part of the United States. So this deep trough that's anchored over the Canadian Maritimes, and we have, this will be this tropical jet to the south and our polar jet to the north. The broad confluent flow with this wave that's embedded in it, moving into this flow, it's going to get just sort of ripped apart. But this is not going to, very likely not be a significant weather producer as it heads eastward. We'll produce some precipitation, some of it in the form of snow, and that's why the Weather Service has those watches and warnings. But it's not going to be a big player in terms of becoming a significant East Coast event. This feature, however, we'll see when we look at the forecast and the evolution. I think we'll have to be able to maintain its integrity as the things begin to change off the eastern part of the United States, over the eastern part of the United States. This pattern obviously is one that's going to be favorable at the surface for developing anticyclone with subsidence in this region. In the lower troposphere, we might expect to see heights rising or pressure rising to the surface, and we'll see how that also sets the stage for a more interesting weather event by midweek next week over the western part of the United States. But a really broad, nice classic split flow with this low traffic sort of in the ridge, and then we have this confluent flow all over the eastern part of the United States.
And you're right, that thing on the south is a subtropical jet. I think I looked at the 200 millibar winds this morning, and you can see it's all the stuff in the northern stream disappears at that level. See, so yeah, all the northern stream wind maximum disappear, and it's all in the southern stream now.
It's all down here, so this is
really nice.
the tropical jet. Now, one thing we can do, just on the fly, is construct a cross section through this jet if you want to get a look at the structure of this. Now, let's go to the tropical tidbits.
No, you can't.
Yes, we can. No. Yes, we can. Okay, the one that they're already here, it's right under the So let's, just to orient ourselves, let's go to the, every day, so let me get myself oriented. But then we'll do the cross section, we'll use the thickness number as a guide. So we'll start up here, and we'll just go southward or south-southeastward, not going along the latitude, so we'll stop right there. And we submit for this, we can change the perspective. So this is a cross section, 300 millibars. We're looking at theta in these aqua type colors. This is temperature, freezing line. Actually, first of all, look at it will change this perspective that's being shown here. Let's first look at the potential vorticity, and then we'll look at the normal wind for this. Okay, so this is from 100 down to 1,000 millibars off the west coast. This is, you can see that sort of that double jet structure that we sort of hinted at. This is the tropical jet. I would imagine this is the polar jet that shows up here. Again, just to orient ourselves, these warm colors in the fill pattern are potential vorticity. The 2 PVU surface are dynamical tropopause. There's that dashed line that's shown right there. The blues are sort of the tropospheric values of PV. They're typically low, quasi-uniform, but really strong PV gradients along isotropic surfaces. And we also have the jet, we have isotax for the jet. This is into the board of 140 knots. We're into this cross section, or actually out of the board, because we're looking from this perspective. This is from A to B. A is over here, B is over here. A nice cross section feature that we can do. We can even step forward in time on this if we wanted to. Won't do that just yet. I think there's some interesting things we could probe the East Coast storm, because the data goes back to Monday. It's going to do some cross sections and sort of lead us through that direction.
It's really fun. I'd like to see how it works. Can you decide what variables you want, or is it just from that type?
From what's available here. So here's the normal wind in the cross section. And then if there's the orientation, you can see that, and you can step forward in time or backward in time. It's used to do that as well. This is another tool we'll add to our arsenal of things that we display. A lot of good features on the web, and maybe we can even suggest things to these guys. You can also change the model that you're looking at.
Is there an archive of this, or is it just like real-time models?
It's just the real-time models. It goes back maybe almost a week or so.
All right.
Okay, so let's get out of this for a second and let's look at the forecast, finish that up, and then I'm going to go back and look a little bit at this winter storm that occurred on the east coast of the United States. So we'll go to Sol over here. No, that's not it. Where is that? Right here. It's already set up. The meteorogram for the weekend, John's favorite term. Again, this is from the MM5 run that we do, 90-kilometer resolution grid over North America. Here's our temperature dew point traces for the next 60 hours and forecasted precipitation. And fairly boring with no precip forecast. The trend over the weekend is upward and maybe reaching 50 perhaps on Sunday if this bears out. And the dew point is slowly creeping up, but it's going to be virtually unnoticeable dew points below freezing, which is nothing to get too excited about. Let's go back and look at our timeline section, please. Probably for the first time in months, it does show up. So the dynamic control ball showing up here. It's the 1.5 PV contour. If I selected 2, you probably wouldn't even see it. But again, to familiarize ourselves with this, these yellow contours are our isotropes. This is vertical motion. So there's actually a little puff of vertical motion over us later this evening, but the column is dry, relative humidity is below 70%, at least in this forecast. So even though we have ascent occurring, not much in the way of cloudiness, and certainly no precipitation forecast. And these isotropes really are kind of level, so it's just warming up the surface, not much really going on in the mid-troposphere. Again, I think the definition of a quiet weekend for us. Let's go up and let's click back. And first of all, look at the potential vorticity in this 305 to 315 layer. We're going to start at 6 hours. You can see that really nice cutoff feature in the, or nearly cutoff feature in the potential vorticity right over Nebraska and Kansas. Broad area of low potential vorticity is under that broad ridge. And then you can see the high PV with the cyclonic circulation off the east coast of the United States and eastern Canada. So this feature here is the forecast expectations for it to move toward the east. You'll notice this broadly confluent flow to its east. So as this PV structure begins to enter that confluent flow, expectations is to get ripped apart. This is a much more potent upper trough with higher values of PV at this level. So we've seen the updates dipping downwards considerably off the west coast of the United States. That's consistent with the cold dome that we saw beneath it. Let's go ahead. Let's go 12 hours ahead. There's this PV maxima moving eastward, beginning to totally get cut off from the big reservoir. And again, this broad anticyclonic circulation over Canada is to protect us. So let's go forward.
That's about the time where we had the little plume of vertical motion too in the upper middle troposphere, right?
Yeah.
It's really interesting that, like you said about the West Coast feature, it has a deeper penetration, stronger PV at this level.
Mm-hmm.
So that one gets the impression that the circulation associated with the one closer to us is doing all the dynamical rearrangement of the mass field in the middle and upper troposphere. You can't get its feet down to the ground.
Right.
You know, and you saw that in the data, that you got a really strong stable layer that's down there, and it's hard to move the air anywhere.
Right. And this is just so small in scale, its influence in terms of how it's going to perturb things is going to be as significant as something that's large scale like this.
That's right. And penetration depth is a function of that length scale.
That's right.
So that even with delta stability, you got problems.
Again, if we did a cross section of this, we won't do it, or a timeline section of this. We'll probably see this captured because this is well or south. It doesn't really show up. All right, let's go ahead. We'll go access to 30 hours tomorrow. And you can see, remember, it was a bit more circular. Now it's getting a bit elongated as it heads into this. Again, it's broadly confluent. You can see the confluence on the northern side of this as it enters that region. But downstream of it, there is going to be weather to contend with, but it's not going to be, it slips well to our south, so we're in good shape. Okay, let's go ahead to 42 hours. You can see it's really getting stretched out as it moves to the east, off the, through southern Virginia, south of Roanoke. And we have this next big trough that's now moved almost fully onshore over the western part of the United States. Let's go ahead and run the 60 hours just to end this sequence of maps. So this feature now is just Also probably getting diabatically eroded as well as we move offshore. And we have this next really deep trough that's moving to the central, beginning to move into the across the Rocky Mountains. Go back a click. And let's just animate this. We've seen the same picture, but we'll look at 500 millibars, look at vorticity structures there. And there's that trough kind of getting stretched out. And we see the next one as it moves around the big deep trough over the western part of the United States in the PV field, heading over the Rocky Mountains. Maybe we'll take a look at the last panel of that at 60 hours. Yeah, really nice curvature maxima. Probably lots of ascent downstream of this downstream of this vorticity maximum going from cyclonic to anticyclonic curvature. This will be a favorable region we might anticipate to see some surface cyclogenesis in the late of the rock. Right, so let's look at the surface maps. Let's start at 6 hours and then we'll go forward in time. Look at the precipitation with this. This matches up pretty well what we've seen currently ongoing in the radar, as well as that precipitation in the southeastern part of the United States, showery weather off the west coast, and the unfortunate snow showers in New York City. All right, let's go ahead to 18 hours. So this is valid at 1 a.m. now. And so precipitation in the southwestern part of our state, perhaps, but we're sort of high and dry with anticyclone over us. And we'll just keep moving forward, watching this low, begin to weaken 2007, 2010 now, with a light precip extending down into West Virginia and Virginia. And 42. And then not even a close contour at this point, as this is weakened out. So the upper level trough is weakened, surface cyclones weakened. There's variclicity here, but it's not able to really intensify. And also see to the north, pretty sprawling anticyclone over central Canada. That's something we'll watch for with cold advection behind it. So let's go ahead to 60 hours, 2032. It weakens a little bit, but pressures are beginning to rise over the central and southern, southeastern Canada. And that's going to be important, I think, for weather along the East Coast beyond this time period. So this is Sunday evening at 7 p.m. Broad Ridge to our north. Winds turning to the northeast, I guess, over parts of Michigan and the northern part of our state. So maybe weak cold advection. And it'll be interesting to look at the GFS forecast beyond this time to see how this anticyclone evolves. The Gulf of Mexico is open, so to speak, with southerly flow. You can see the precipitation. We have cold air pressing in over the eastern part of the United States. This could set the stage for a snow or an ice storm, perhaps, beyond this time here. Let's get out of this loop for a moment. Let's go to the GFS. Just one thing, because this is something that Brian is made useful. Let's first go to our quick links. Go to the GFS plumes. Let's look at a couple areas of forecast precip. We'll zoom in a couple clicks here. Get over Madison up here. So these are forecasted. Take the GFS and its ensemble members. Blue is the control forecast. These are the ensemble members. Black is the mean of the ensemble. I'm looking at just total precipitation since in the winter. Let's assume it's snowy, but it's going to be warm this weekend. So please, John, I think. And you can see sort of a range of potential forecast amounts during the course of this weekend. So this is every day out to October time. So this is 17th into the 18th. This is tomorrow. Again, and some of the GFS forecast members actually bring precipitation over us, maybe just an inch or so of precipitation. And then beyond that, even more. So control forecast is dry. We'll see that when we look at it explicitly. This is the mean of all their 20 ensemble members. And then you can see a couple of the outliers. Is comprehensive. Can we make some sort of probability forecast from this alone? Probably not. But it would be interesting if we had access to it, as we do at some level, each of the ensemble members to see what are these doing? What's going on here? And I think John would be more excited about what's going on the 20th.
Yeah, that's the one event. It all comes in one event in that one.
Yeah.
It goes from 0 to 5 inches of snow in about 12 hours.
That's kind of an interesting conundrum. And I imagine the spread gets further, it's even broader if you go to the south. Let's go over to Rockford. Yeah. Rockford. It's a little more in terms of precipitation, but again, it's maybe something this weekend and maybe something midweek, recent-wise, but the control forecast is correct. So let's take a look at the GFS in the pivotal for that. Actually, since we have tropical tidbits, let's just bring that up. We'll go forward using this. And look at the surface. I'll just focus on the surface. I can step forward for this every 12 hours. So this is the GFS. Our MM5 was initialized with a different model forecast, but you can sort of see the same pattern if you just step forward in time. Here's that snow and rain. There's some ice just to our south, frozen precipitation. You can see that low just weakening over time as it heads toward the east coast, just sort of fades out over time. Whereas in the western part of the United States, as we get toward, this is not quite 60 hours, you can see the beginning of a new cyclone in the Rockies as we anticipated, with that deep trough moving across the Rocky Mountains. Let's get to 60 hours of forecast. More stuff, I think that's it, right? So 60 hours. Here's that cyclone beginning to develop. And we mentioned the Gulf being open with a lot of precipitation over the central part of the United States. Snowstorm back in Colorado in the northern plains. And let's follow this cyclone as it heads eastward. And then look carefully at what's happening in the northeastern part of this map, broadly over eastern Canada. Step forward in time. Here's this broad anticyclone. We're getting the continued cold advection here. The cold air is getting locked in here. It's not significant cold advection, but pressures have risen significantly over this forecast sequence. And we have, again, the beginnings of the cyclone moving into southern Indiana. Broad area of just liquid precipitation with some frozen and freezing precipitation on this northern edge. And for us, we just stay chilly over this time period, but dry. And watch, this is a nice sort of cold air damming event with cold air trapped up against the the Appalachians. And you can begin to see frozen precipitation now in Maryland and northern Virginia as pressures fall to the south. Let's go ahead another quick. Another snowstorm for New England. And this is one situation where we have a nice cold anticyclone to the north and a very vigorous cyclone to the south.
More classic.
That's more classic and also probably more slow moving. Right? Just take this just from the setup.
I'd say it has more classic ingredients, but again, the track of this thing is not the classic track. It doesn't start in the Gulf of Mexico.
Right. It's one of these.
Well, there's two
jumps
kinds. There's a kind from the Gulf of Mexico, but there's a kind that comes
Miller type
across
B.
and reforms off the Hatter.
Right. Miller type B.
That's right. That's
Type B.
the secondary.
Yeah.
Redevelops. How does the secondary develop?
That's a
No one's
that's
ever
a
answered that
question,
in
right?
literature.
Well, the secondary, it's on the Gulf Stream.
Yeah, but I mean, how does it develop? Who's done a
Oh,
case study
well,
with
because-
secondary development? Nobody.
I think it's the apple, it just appears on one side and then the other. It's actually continuous in the upper air movement, but it doesn't really appear ever at the apex of the Appalachians. It just disappears on one side and reappears on the other.
So an interesting thing to do with one of the tools that we have these adverent models, we look at the sensitivity of the development to the upstream troughs for these so-called Miller type B events that differ from Pedersen type B. I think this was a paper from Miller in the 1950s, right?
Yeah, that's
That
right.
talked about these, the move from Ohio Valley and get a redevelopment to the southeast. Here we are with sort of, a moderate precipitation event from the mid-Atlantic all the way to the northeast. And it's just a nice structure to keep,
Solid
some of these
snow in
areas.
southern
So,
New England again.
let's go ahead.
40 thickness line is down into the Gulf.
Right, so that's a cool thing. And it just persists.
Oh,
Broad trough,
Man.
more snow.
got the totals somewhere?
Get that,
It's gonna be more because this thing's coming up the coast again, right?
yeah.
That's
Yeah,
a
so
third.
It snows. Look at that. That's a long period of snow in southern New England.
But I'm gonna guess that a lot of this on the south side of this, the temperatures are probably just around freezing or slightly above. So in northern Maryland, Delaware, those areas, it's probably not cold enough. There's a total snowfall, assuming 10 to 1. Maybe we should take that back. Look at some of these amounts here.
16 in central New Jersey.
18 through here, and these purple areas are 3, 4, 5 inches of snow forecasted through this time. Again, that's, if you actually look at snow depth, is there a snow depth on this?
That's Philly and New York at 18.
So let's look at snow depth here. How does the snow depth change? Yeah, let's look. We don't have something that says what's really expected to be there. So try this. That's over 24 hours, I guess, how much has gone up.
Yeah, roughly.
It's not going to show us that. Well, yeah, it's always positive, so it's not going to show the melting aspect. I think the pivotal site's a little bit nicer, you can actually see the deck and see the melting that's occurred.
It's unbelievable.
But, again, we're high and dry, and it's, surface precipitation just north of DC and Baltimore, moderate to maybe the heavy snow through everything. We can keep looking at that in the other parts of the country for sort of interesting weather, but for us, pretty quiet. So one of the things that I thought was really interesting, particularly with this site up today, and with some time, maybe John can join in and help me out with this. Let's look at the snow event that occurred in the eastern part of the United States earlier this week. So I think it was a big event on Monday or Tuesday. I want to make sure we get the dates right. The Monday afternoon that we were looking
It
at.
started Monday afternoon, so if you use the 12Z March 12th initialization, you get the whole development, I think, in that one. I think that's right.
Okay, so we'll look at the surface, we'll change our variable here to 11.
No, the 12.
And let's change this out, change the variable we're looking at. And while this is getting set up, just again, a recap for the weekend for us, sunny, maybe some clouds to the southwest of us over the weekend and south of us over Saturday into Sunday, but cool weather or warming, moderating temperatures into the 40s and maybe close to 50 degrees. But right now it looks like it's going to be dry. With sea level pressure and this will work. This is wind. I'm not a precip on it, but yeah, there's a precip. Yeah, this is great. Okay, so this is the setup, and we're looking last week at the development of the cyclone along the east coast of the United States. A couple of things to note, and again, flipping back and forth, this is not a well-rehearsed or practiced presentation here for today, but one of the big concerns that we're seeing between a lot of the model forecasts was having a really robust upper trough that was going to interact with the nascent surface cyclone and trigger the development. And I don't think we would have imagined from the forecast that we saw last week anything that was going to have even a thickness trough that was going to be this sharp.
Yeah,
I could agree with that.
I do.
So this is something that looks totally different. If you look at the satellite imagery over Monday afternoon and Monday afternoon and evening, really well-developed upper trough that went through the southeastern part of the United States and began to interact with this wave along the east coast.
So where do you think the weakness in the models is that's not picking this up?
I think if we were to trace this upper trough back in time, that may have been one of the sources of the error. It was also the confluent flow. How well did it have the confluent flow initially that was ripping these apart, and then it relaxed for just enough for this to fall up?
We noticed that it was the curvature vorticity was very mixed up last week when we looked at it. It wasn't very organized.
Yeah, and so what's the factor that actually helped us get?
I wonder if it was more organized from the get-go, that it was just diagnosed
In the
poorly
forecast,
when it was up in Canada, when that vortex was up there.
that's entirely possible. We have the tools to look at it.
Yeah, or it develops in the northwesterly flow and it becomes a sharper, deeper tropopause protrusion than
Right.
forecast. And that makes it easier to organize its
But
own
there must have been
information.
something wrong in the initial condition for that to be the case. The physics are there to do it.
Yeah. Something about the orientation of the isotherms to the flow or something about the flow speed itself. Yeah, that's right, something like that.
So an interesting problem for anyone here that's a junior wants to work on the interesting problem. This case will be one that's certainly going to be looked at. But let's step ahead just carefully. Let's look at the organization of precipitation in this. And maybe this is not the best model to look at, but the GFS let's just take this move forward. So this was forecast to deepen and intensify, and then we had this. It doesn't really show up here. I wonder if we want to dare change models. Let's go back one click. And I don't want to mix things up. Do we have access to a different model that would allow us to the mesoscale for a second? Do we have the NAM for 3 kilometers? Check it out. We have that for that time period. Do we have that? Okay, this is good. This is good. And we want to go back to clicks. Monday, 12 Let's go to $36. And not a great forecast, we'll go to 24. From this time. So we should have the ability to actually do a cross section through this band. And so let's take a point here. We're going to go a little bit east of the northeast.
Yeah, northeast of it. That's perfect.
Yeah, I don't know if this is going to go off the grid or not, so bring that in a little bit. Oh, see if it takes it. Not jump back. Okay, so what's shown here, we have a lot of interesting things that are shown here. We have the frontogenesis in pink in degrees Kelvin per 100 kilometers for 3 hours. We have theta E, degrees Kelvin. Those are these aqua contours. And we have the vertical motion, omega, negative and upward, if you recall, it's a pressure vertical motion along this front. So clearly, in front, there's some modest frontogenesis at the surface and tilting back even behind this dark clinic zone. And you can see the 0 degree line down at the surface. So just about halfway through here when it crosses the coast, going from rain to snow. Not as dramatic as I was thinking.
Well, there are maybe arguably 4 separate updrafts along the front, sloping along the front. There's,
1, 2, 3,
and then the weaker one there, yeah. And the last one of the, in between the last two, the ones farther to the west, you actually see an undulation in the theta E. So it's almost as if it's been worked by the circulation a little bit between those 2 updrafts.
And we have a local, I'm sorry to get my presentation on this. I mean, theta E generally, or much of this is increasing with height. So this is going to be.
Remember when we looked at the actual radar, they were very banded structure.
Yeah.
Right.
And I wonder if those vertical motion maxes are the model's attempt to create those bands.
Yeah, right. And yet, as you're pointing out, Michael, it's potentially stable. Gratification is potentially stable.
But I see those bands is with the curvature, those bands are probably slant-wise convection.
I know, but it flow's so strongly curved right there. That's why it's kind of like this weird hybrid. How do you diagnose it?
Right. So I mean, really strongly curved from the isobars and it probably 850 as well. But it can be stably stratified to vertical displacements, but it's those lateral displacements that the CSI is going to be the more important thing. Let's look at the PV for this. We can change this.
The theory just doesn't account for strongly curved flow. That's the thing. It might still, something like it might still operate, but it's not.
What theory?
The slant-wise convective theory.
Well, it's only for curved flow.
No, it's only for straight flow.
Straight flow.
2D flow.
No,
We'll see a side theory.
but the angular momentum gradient. The angular momentum is for curved flow. But see, you can do it different ways. You can do it relative to the pole, but you can also do it relative to the curvature of the storm. So the angular momentum of the storm is the curvature of the storm.
You're talking about stuff I don't understand.
So
The traditional.
you know what I'm talking about?
No, I think that was, the form, when it was introduced, it was they took cross sections through a fairly straight part of the flow.
It's exactly for the.
It's the classic, right,
Yeah.
the classic view of this was, doing these cross sections through it and then looking at you can calculate angular momentum in these M surfaces and look at the slope of them relative to the theta E.
But that was where you're defining angular momentum relative to the pole. But if you.
No, it was in a cross section.
Yeah, it's in a cross section.
In a,
You can
normal
change
cross section.
the horizontal momentum equation reduces to a conservation of M if you don't allow for ageotropic along the front flow.
That's the symmetric part of symmetric instability. It's
yeah.
flow being symmetrical.
But that angular momentum was based on F, right? Not the
Right.
F times X.
Right, but
Right,
you could,
right.
but like in a tropical cyclone, you have
They flare out.
the bands going up on, that angular momentum is based relative to the center of the
Cyclone
Oh,
storm.
so there's another way that you can do
Yeah,
this.
you can do it, I've done it that way many times, you just compute
Oh,
the
I've
angular
never seen
momentum
that.
relative to the center of the storm,
Okay.
and I think that's what's going on.
Can you actually derive a diagnostic in that context so that you might be able
Yeah,
to
I
pinpoint
have it,
those?
I compute that. yeah.
Well, that's neat. I mean,
But
that
you have
might
to
be a way
say
to
where
do
the
that.
center of the storm,
Yeah.
but once you define that, then you get the angular momentum relative to that.
Okay, cool. So a couple things that are interesting in this cross section. This is the potential vorticity, and one of the sort of classic things to look for would be, this is probably just in the cross section, is for the geosurface potential vorticity to go negative. What's interesting here, we have a nice band of positive high values of potential vorticity right along that frontal interface. But the other thing that's really neat about this particular event, these are ice attacks. There's 60 meter per second ice attack just above the ground at some of these locations. These go all the way back 60, Missouri 10, 60, 50, 40, probably into Worcester Hills back here. Really strong winds just above the ground. So a really strong jet. And this is going to be going in A to B. So this is positive is this way.
No,
Yeah.
oh, the other way.
Way out. That's going in onto the cross section. A really broad, deep reach wind out of.
And there were widespread wind damage reports in southern New England,
Right.
and wind gusts at the surface well over 45, 50 miles per hour. There were a whole bunch of them in the storm reports.
So this is a 24-hour forecast, 3-kilometer grid, and it was capturing this really intense jet, low-level jet, just to the east of this, this barrack, or to the west of the barrack.
Yeah, so this does not conform to, at least at first glance, to the classic two-dimensional conditional symmetric instability theory as the explanation for those bands. So you have to do an extension, storm relative extension of that, because the moist PV is positive here. This is the drive. We already saw the theta E doesn't have any potential instability in it. And
If you do the storm relative, you'd want that cross-section to go through the center of the storm. And going outward.
And we don't always redraw that.
Yeah.
I mean, there are a few areas where this PV, at least in this cross-section, does get low, but unfortunately we can't see.
You know, another way you can tell that, Pete and I have done this before. Remember, Pete, that's what we did on your thesis. But we can, if you draw the cross-section through the center of the storm, and you look at theta E on that cross-section, you should see the theta E parallel to the slantwise direction. I'm not sure, unless you have those momentum lines, you can't. But sometimes you can see the theta E going up the slope. You'll see little perturbations along it that go up.
Yeah, that's
I mean, you're seeing it right there, but with the theta even,
But look at this, it's probably
Yeah.
right through our convective.
upright convective. Right. The frontal part is on the
That's off in the
left
right
half, the left half of it.
Right. And you can also see that the theta E is actually, it's almost neutral. Right?
Yeah,
Assuming this-
yeah.
We actually,
Right.
oh, yeah, but look at the theta, no.
let's do what, let's
No,
do.
no, that's slantwise, look. What you see.
Yeah.
Here's the convection. Pointing right up here. This is the convection block. See that nose coming up
Yeah,
there?
yeah, yeah.
That's the convection of the angular momentum surface. I'm sure the angular momentum surfaces are going up this, and it's convecting up.
So that you think they're parallel.
Yeah.
So this, and that's consistent with, this is omega, it's slantwise.
Yeah.
Right through here. And here's a vertical, obviously a vertical convective flow. And that's theta E almost constant with height.
Yeah, but there's the other one that's up there at the -5 isotherm, the red isotherm.
It's saturated too. It's saturated. You know, go back to the one.
See the updraft that's more upright,
Right here.
about 179 kilometers. Yeah, that's upright convection. The one that's
Up there,
further
yeah.
along the front is
Elevated.
Right.
I thought that's the way that this worked. You actually have motion slantwise along,
Yep.
if it's neutral or unstable, you have motion that's slantwise, and then you rearrange the theta E surfaces so you get local potential instability, and it turns into upright convection.
You can, that's what's happening at the bottom there, but because you see the theta decreasing in height. But actually, yeah, you get those theta E surfaces going up, and then you can get places where it becomes conditionally unstable, and you get slantwise.
Yeah, because that's a much more efficient way to
Yeah.
drive the free convection than along the slantwise path.
Right.
PV for the same region. And yeah, the front, there's a, look at the 70 knots, that's just nuts.
See, I think this is so strongly dynamically forced that all you need is something close to neutrality, and you're gonna get 22 inches of snow in Boston. That's what it took. It wasn't really maybe even release of any free convection, slantwise or otherwise. It just didn't need to. Wasn't there an absence of thunder snow reports
Yeah, that's.
Yeah,
in
that's right.
southern New Hampshire? I mean,
And there's-
southern Massachusetts?
There was certainly no lightning with this, all the lightning reports,
Yeah.
just for the cloud lightning were all well offshore to the east of the cyclone, the northeast of the cyclone center. Really just neat,
Yeah.
look at this strong jet, low-level jet. I mean, this is-
Amazing jet. This reminds me more of the megalopolitan storm, the Sanders and Bossart work on that, where they kind of show that cross-section where they've got almost perfect slantwise neutrality, but strong frontogenetic forcing. I think we have strong dynamical forcing here and probably nearly neutral stratification. So the air just moves wherever the frontogenesis tells it to,
Right.
with no energy expended.
But when you're neutral, if you bring in extra moisture, extra.
Yeah, and then you change
theta E,
theta E enough that you get
Then
a
it's
conditionally
gonna go
unstable.
vertical.
Yeah. That's all convective unstable. Yeah, that's right. Yeah, so what a great situation.
Yeah, so in this cross-section, yeah, this is, how you choose a cross-section, we saw a lot of differences, even this popping up, we didn't expect it. But, so the frontogenesis, at least the 2D frontogenesis that's shown here are these purple contours right here.
Yeah.
So it's not, at least in this cross-section, this is probably the most favorable one.
Yeah, I saw on Vis 5D, it's really interesting you point that out, looking at Vis 5D earlier this week. I think the same time initialization. The warm front has a really intense frontogenetic band that has a very sharp western cutoff. And I think the angle from A to B here just past that western cutoff. Because you showed in the prior cross section with B displaced a little bit to the north and east, you have really strong frontogenesis.
Right.
Through a deep layer. It's really quite
We do it.
restricted.
Which one? So there's a cross section, let's get rid of this and let's reorient it, more like this, you think?
Yeah, to the
It's almost
northeast of the
perfect,
cyclone
right?
center. So you're almost perpendicular to
Yeah.
what you think is the band.
Mhm.
Too bad we can't make them longer because the aspect ratio is always better when they're longer too. But
Oh, look at that,
yeah,
oh,
there you go.
look at that, that's
Big
a
difference.
nice strip of frontogenesis.
And you're
right
only
here.
starting.
And this is what this is what you're gonna expect, almost
It's
textbook.
precisely what you expect, yeah.
Right.
You
And
see
also
those
look at
data
this-
lines
yeah,
coming
this-
up there.
Yeah, like that.
Yeah,
all the
so,
way.
yeah, so 315 or 313 Kelvin air is kind of moving up along the escalator, and then occasionally it produces convective instability, and boom, you get these things flaring up.
But that's all held, that's kept in that very stable, classic slanted pattern like that because of the curvature.
And I think I see what you mean now. I guess I
Yeah.
never thought of that.
The curvature
I'd
is
like to see
driving.
that in some more detail, but I think I know what you mean, yeah.
Really.
And I'm sure, I mean, just having done this before, if we draw the momentum lines on the relative.
They'd be about parallel.
They're totally parallel.
Yeah.
Let's see, for this one, I'm just eager to see a PP that's close to zero in that region.
If it was moist peak, it'd be almost zero.
Yeah.
We can't do that, it's a dry peak.
Anyway, well, I just thought this would be a useful tool to,
Oh, yeah.
and this begin interrogating, this really exciting storm, but again, this would be a great case study for 452 or just a research project if someone's interested in looking at this. I mean, there are a lot of issues with it, right? We have just the history of the upper precursor and why was it poorly forecast, what were the uncertainties associated with that? Then you also have this really intense sort of mesoscale banding of precipitation, and can we attribute it to CSI, traditional symmetric instability, probably not fully upright, or some mixture of sort of upright convection and slantwise.
I think it'd be really fun to try and, as best you can, pin down the frontal structure over southern New England, the one frontal structure, which is really intense, shallowly sloped, but really intense jet underneath it. And then try to do like a time-space mosaic of when do the bands, how are the bands moving along
So
that
isochrones.
frontal structure. Yeah,
Isochrones.
isochrones, I couldn't think of the word.
Mhm.
So you watch the bands move along that structure and just, depending on the resolution of whatever simulation you're looking at, do you see anything that corresponds to that? Really interesting.
Exciting storm.
Great.
And looks like we'll probably talk about another midweek storm over the eastern United States next week. For you guys, right?
Yeah.
Okay, well, thank you all for your participation coming, and Pete for driving for today, and see you next week.
Thanks very much.
Okay. A lot.